Alright, in this video I'm going to cover the ins and outs of the box and whisker plot. Box and whisker plot. And this is one of the most useful little graphs for telling specific information related to mean, median, and the minimum and maximum values. So you're going to see it kind of looks like this. We call these the whiskers. Then inside of those whiskers is a box, and there's usually a little line on that box, as well as another whisker on the end. So that's where the box and whisker plot name comes from. And it's kind of broken into several parts. We call this end part the minimum, and that's going to be the smallest number in your data set. And then over here we call this the maximum, and that's the largest number in your data set. And these do change when we get into things called the lower and upper fence, where we start cutting out outliers, and you might have a value that appears in your data set way out here that's larger than your maximum, but it's such an outlier that we don't include it in the box and whisker plot. But for your basic one, rule of thumb, your biggest number is going to be your maximum, your smallest number is going to be your minimum, unless you have a weird data set with big outliers. And then this little line in the middle is your median, and that's your middle number, right? The number that appears in the middle of your data set. In the edges of your box, we're going to call Q1, that is for quartile 1, and that's going to be the median of the lower half of your data, and we'll get into that a little bit. And then you're going to have over here your Q3, which is the median of the upper half of your data set. So you can kind of think of all of this stuff that appears in the first half is the first 25% of your data. And this is the last 25% of your data. Then everything in the middle is your middle 50% of data, split into kind of two halves, this 25% and then this 25%, right? So let's do it with some actual numbers that we can utilize to make a box and whisker plot, and then we'll break into things called lower and upper fence. So let's take the data set. This one just is from the Carnegie text. Let's say we had all of these values, 4, 4, 7, 7, 7, 8, 8, 8, 8, 9, 9, 9, and 12, 12. And these are just random values for us right now. But we do know that these numbers stretch all the way from 4 to 12. So when we make our number line that goes beneath the box and whisker plot, and if I were taking notes on this, this is something that I would find valuable to copy. I would start at 4 here, and I would go up until I get to 12. 5, 6, 7, 8, 9, 10, 11, and 12. And if you were doing this digitally, which is where it's commonly done in Excel or something like that, numbers, you would have more evenly spaced graph that would be all perfect and pretty. But unfortunately, when we hand draw them, we can't quite match that level of precision. And what we're going to first find is we're going to find the median. And we're just going to start crossing out numbers evenly on each side. So if I do 4 on one side, I got to do 4 on the other, 5. And then I find that my two middle numbers are 8. We'll add 8s together and I get 16, divide that by 2, and that tells me that my median value is going to be 8. And that's because this is my median. So I'm going to kind of make some notes down here that this is my median and it's 8, right? And then the next thing I need to be able to find is I need to be able to find the lower half, so the lower section of data, that would be from this 8 down. I need to find the median of that data. So I'm going to take my highlighter, I'm going to go in green, and I'm going to say, well, the median of the lower half is going to be 7. That's the central number on the lower half of data, and that central number on the lower half of data we call the Q1 or quartile 1, and we're going to call that 7. So our next end of our box is going to be here, 7. And then we're going to do the same thing with the upper half of data. Let's do it in red, so we just have something to differentiate. And we go, oh, get rid of that, get rid of that, get rid of that, get rid of that, that, and we are left with our quartile 3. Our median of our upper half of data is going to be 9, so it's going to look like this. Then we do our minimum and our maximum. We say our maximum value, our largest value in this data set was 12, so it's going to be the edge of our whisker. Our minimum is 4. Maximum is 12. And we draw it out, and draw it out. And now we have a graphical representation of this data that tells us the median, the Q1, Q3, minimum, and maximum. Now, we need to analyze and see if there are any outliers in this data set. And there's a formula to do that, and it's related to something called the lower and upper fence. And the fence basically just sets where the outliers are allowed to be. So if I were taking notes, this would be a very important time to write down the formula. So if we take the lower fence is equal to the first quadrant's value, quadrant 1, minus a constant called the IQR times 1.5. Sorry, the constant is 1.5. The IQR is going to be a number that changes. And then to find the IQR, the interquartile range, we should have done that already. Sorry for that. The IQR, the interquartile range, when we say range, we are just subtracting the largest value from the smallest value. We're going to do quartile 3 minus quartile 1. So we do 9 minus 7. And we find that our interquartile range in this situation is going to be 2. Because 9 minus 7 is 2. So in our formula for our lower fence, we're going to take our Q1, which is 7, and subtract it from 2 times 1.5. 2 being our interquartile range, 1.5 being our constant used for the formula. So we just math that all out. We can do it in our head. We can throw it in a calculator. 2 times 1.5 is 3. 7 minus 3 is going to be 4. So our lower fence, the value that is the lowest possible value in this data set, would be 4. So our lower fence runs all the way from here. That should be a fancy bracket, but I'm not very good at them. Here, this is our lower fence, our range of acceptable values for this data set. Now we're going to do our upper fence, upper, and it is going to be very similar formula. It's going to be Q3 plus the interquartile range, the IQR, once again times 1.5. So we take Q3 and we say, well, Q3 was 9 plus our interquartile range of 2 times 1.5, 9 plus 3, and we say our upper limit for this data set was 12. So all of our data actually fits inside of our lower and our upper fence. This is not always going to be the case, but usually if you have an acceptable set of data, this is going to be the case. Let's look at another set and do this as a practice problem so that you can follow along and try to keep up with all of these things. So new, fresh set of data. We are going to take the data values 2, 5, 5, 5, 6, 7, 9, 10, 12, 12, 12, 14, and 32. And we are going to go ahead and go through it, and we're going to find all of our things. We're going to find our minimum, maximum, and we are going to find the median mode, median, everything that we need in order to make this box and whisker plot. Minimum, maximum, median. So our minimum value in this data set is 2. Our maximum value is 32. And then to find our median, we are going to just go all the way across. And we find that our median for this data set is going to be 9. We can find our Q1 by taking all of the numbers prior to 9 and doing this same thing. 7, 2, 6, 5. We're left with 2 5s in the center, so our median must be 5 for the Q1. And then for our Q3, we can do the same thing above the 9. We can go 10, 32, 14, 12, and we can find that our Q3 is going to be 12, which gives us an interquartile range of 12 minus 5, so that tells us that it is 7. And then we need to find our fences prior to graphing. So we have our minimum, our maximum, our median, and our interquartile range. All that's left to find is our lower fence. You can write out the formula again. It's Q1 minus your interquartile range times 1.5. That 1.5 is a constant. So Q1 is 5 minus interquartile range of 7 times 1.5. We're going to realize very soon that our interquartile range can be a negative, or our lower fence can be a negative number. So 5 times 10.5, our lower fence can be any number that is larger than negative 5.5. So we realize that on the bottom half of our data set, we have no outliers. We do our upper fence, and if you're looking at the data, you can kind of see that that 32 doesn't really fit this data set. So we're going to see if it is actually outside the realm of reasonable data. Q3 plus IQR times 1.5, we get Q3 of 12 plus our range of 7 times 1.5. 7 times 1.5 is 10 and a half. 10 and a half plus 12 is going to give us 22.5 as our upper fence. What that tells us is that the actual highest value has to be below 22.5. So what that does for us is it cuts this 32 out of our box and whisker plot and makes it an outlier. So when we make our box and whisker plot, make sure I use the right color here, we do not need to include this 32. So let's go and we will count from negative 10, negative 5, 0, 5, 10, 15, 20, 25, and just so that we can include this 32, let's make it a little bit longer, 30, and 35. So our 32 is going to be somewhere out here. We're not going to actually put it on the box and whisker plot because it falls outside of the realm of reasonable data. Our maximum value is now the number beside 32, which is 14. So we're going to put our first whisker on 14 and our smallest whisker all the way down right below that at 2, because 2 is our minimum value. Our median is 9. Our interquartile, or our Q1, is going to be 5, so our box is going to go to 5, and our box is going to go up to 12. And then we're going to notice that our data is kind of skewed to the right, right? Our box is leaning to the right side more than it is leaning to the left. And this is going to give us all kinds of valuable data at a glance. It gives us the median, so we can see that that median is 9. It gives our minimum, which we can see is 2. It gives our maximum, which is 14. And it shows us this value way out here is an outlier in this data set. So hopefully that helps with the formulas for lower and upper fence and for better understanding box and whisker plots.